Effect of pressure on hydraulic, pneumatic, rotary seals, and O-rings. There is always a small gap between the cylinder bore and the piston head or the housing and rod. This gap is known as the extrusion gap and is the main cause of seal failure. Extrusion gap has to be lower for higher pressure. These values are specified in the catalog. Under pressure, the seal material deforms and enters into the extrusion gap, damaging the seal and resulting in premature failure. Use of backup rings or materials with higher extrusion strength in tandem with a backup ring is suggested. Spare age SUA profile on screen is made of nitrile rubber 90 Shore. A hardness is suitable for pressure of 160 bar. Higher the shore hardness, more is the strength of the material. But beyond 90 Shore, A hardness, the material becomes brittle, therefore the maximum limit is 160 bar. But the same SUA seal made in polyurethane can withstand a pressure of 300 bar due to higher tensile strength in its virgin state without filler or fabric reinforcements. Nitrile rubber, when reinforced with fabric, has a higher strength and can withstand a pressure up to 250 bar. Seals with bronze-filled Teflon, as the main sealing element like spare-age PTA type, are double-acting seals. Single seal is used for pressure from both directions approximately 7 mm in thickness can withstand 400 bar pressure. Seals like spare-age PCA types, seals have rubber sealing element with backup ring on both sides enabling the seals withstand 400 bar pressure with an inbuilt bearing glass-filled nylon for higher load. Effective speed on hydraulic seals. Speed and lubrication film. While in motion, the sealing lip is not in direct contact with the metal surface as a shaft or cylinder bore, but is separated by a thin film of oil. Dry running will cause a rapid and steep increase in temperature due to friction, resulting in seal failure within minutes. A critical point to be considered is lubrication property of the media being sealed. At high speeds, the film of oil is often broken, resulting in jerky movements of the equipment, and when the lubrication is restored, the motion continues. Due to the stick-slip problems and the absence of lubrication film, select appropriate design and material of the seal. Teflon material is self-lubricating with fillers as bronze material, making it ideal for application where media does not offer lubricating properties. Please refer spare-age catalogs for maximum surface speed of various seals. Due to stick-slip movement, all elastomer seals like nitrile, Viton, and thermoplastic like PU have a limit of 0.5 meter per second compared to 10 meter per second for seals like spare-age PTA and RTA die where the main sealing element is self-lubricating material bronze-filled Teflon. Another critical factor to be kept in mind is the surface finish and tolerances have to be maintained to get good sealing performance and life. The values are specified in our catalog. Rough surfaces will cause high friction and damages to seal. Effective load on hydraulic seals. Seals have only one function of sealing. Seals are not designed and do not have the capacity to take the weight of rod or piston head. Use of wearing or bearing strips is strongly recommended to avoid the weight of the hardware from coming onto seal, which results in excess interference on one side and less on the other, or damages due to crushing of the seal. Bearing strips are available in different materials for different load factors related to temperature. Higher the temperature, lower is the load-bearing capacity. Bronze-filled Teflon wearing are suitable for temperatures up to 220 degrees Celsius and have a load-bearing capacity of 9 to 15 Newton per millimeter square. Phenolic fabric wear rings have high load-bearing capacity of up to 90 Newton per millimeter square at temperature up to 120 degrees Celsius. Bearing rings have close groove tolerances. Please refer the catalog for the same. If the tolerances are not maintained, the bearing rings will be rendered non-functional.